Hello, and I welcome you all to this wonderful live stream on Euclid's Division Lemma. Well, I'm going to talk more about the topic a little later when we actually start the live stream. We have already started, but I'm going to give a little bit of introduction about myself, about who I am. Most of you must have seen my YouTube videos, must have seen me, must have heard about me. My name, as it stays right at the bottom, it is Vikas Sharma, and I am a math teacher. Now, I'll tell you a little about my journey, how I started as a student just like you and have become a teacher today, and how it is possible for all of you. Well, to talk the least about myself, I was not a brilliant student like some of you would be. I was quite an average student, and I just wanted to basically it math. I had a fear for math, and I'm sure there are a lot of students who have seen who have a fear for math. But my job today, it is not only to tell you that you should not fear math, because I actually believe in it today, that math is not to be feared of. Once you understand the logic behind it, everything is going to become possible for you. So yes, this video I'll tell you a little bit about myself, so how I got rid of that fear. Now, unfortunately, or fortunately, I don't know what to say, whether it's unfortunate or fortunate, but during my 12 years of schooling, I had to change 9 different schools, and with new math teachers, with new teachers for all the subjects, it was really becoming a little bit of problem for me to understand, because every teacher has a different style of explaining, and sometimes you get used to the teacher also. So I was not kind of getting adjusted with the teachers, because every couple of years I was changing schools. Like I told you, in the 12 years of schooling, I changed 9 different schools. Now, that can happen, that can happen to you also, if you're, especially if your parents have got transferable jobs. You might also be changing schools, or you might stay at the same place. But the thing is that once you understand the logic behind a subject, and especially mathematics is a subject which purely works on logic, and once you understand the logic behind it, you're going to excel in the exams. So basically, I was an average student till about grade 6, and that is when, after years of struggling with math, my father told me, and even I got a good teacher also, who explained the logic behind everything, why this happens and why we can do it this way. So that's when I started understanding maths, getting a grasp of maths. And once I got a good grasp of it, I could do everything. So once you get into the problem, try to understand the problem, and then try and approach and see what all things you know, and how you can apply all the knowledge that you have, and you can do the question. So our job today, like I said, that today we are going to do only about learn only about the first chapter. Your first chapter is real numbers, and in that the first two topics are basically Euclid's division lemma and Euclid's division algorithm. So we are going to talk about that. We are going to solve a few questions today, and I've selected a few questions which I think might come in the board exams, though I'm not setting the paper, so I'm not sure whether they'll come or not. But questions of a similar type definitely might come in the board exams, and it will help you a lot. Now, I believe all of you are students of class 10th, and this year, or probably this school year, which will be 2021-22, will be a very important year, because hopefully the pandemic would have been left behind by that time, by March 22, and you would be appearing in the board exams. This year, students, they unfortunately, or again fortunately, I don't know whether what to say, whether it was unfortunate or fortunate, but they don't need to appear in the board exams now, but you might have to. uh, and so today, in today's topic, I've selected a few questions which I'll try and solve with you, so that you understand how they are solved. And Euclid's division lemma is all about proofs and all. So we are that I don't expect you to answer. I just need you to sit back, relax, understand how I'm doing them, and then think about it. In case you have any questions, you can please put them in the chat box, and surely I'll be there to answer them. And I've got a few messages here from Aryan Kumar and Khushi Kumari. Welcome both of you, and hello to a very warm welcome to all of you. So let's start with the team. So once again, now today I'm a teacher, and how I came to be a teacher, despite being an average student in my school years, it's because I've understood the subject now. I've understood the logic behind it, and the same can happen with you. Don't worry if you're an average student right now, but if you understand the logic, if you start applying it right from today, I can assure you you are going to do really well in your board exams. And I wish you all the best. And I'll tell you a little bit about my company today. My company that I've called, it's by the name of Exponent to Success, and this is basically Exponent, is a math term, and uh, we are basically, what I want is that, or the motto, our tagline is that it adds an exponent to success, adds an exponent to your life. So I'll just start with a small video, and then we'll start right with the questions. Right. So let us start with the questions, and like I said, today's topic we are going to discuss only about Euclid's division lemma and Euclid's division algorithm. I would expect you to participate along with the live stream, and wherever you can solve the questions, do solve them and send it in the chat box. I will show your chats on the screen, and congratulate you for whoever you have done them correctly. And so before we start, I just wanted to tell you that in case you are new to the channel, if you have come here for the first time, don't forget to subscribe to the channel, because I've got a lot of videos on class 10 topics, and you're surely going to benefit from this channel. And don't forget to hit on the bell notification also, because that will ensure that whatever videos I upload, they will be sent right into your inbox, or you will get a notification to watch them. If you don't click the bell notification, you might miss some of the videos. That's how YouTube works. I can't really help it, even if you subscribe. So make sure that you subscribe. My target for today is that I should get at least uh, 20 subscribers by the end of the stream. And also, do not forget to click on the like button below the video. And if you have friends right now, just send them a WhatsApp message right now to come and join the stream, so that they also can benefit out of this wonderful stream. Right. So let us start with the questions now, and I'll take you to the questions right away. And what I have here, like I said, we are going to discuss about Euclid's division lemma. Now, before we actually start with the Euclid's division lemma, I'll just try and give you a simple understanding about what Euclid's division lemma is. And so basically, I've got a concept. I will explain you the concept, what the concept behind Euclid's division lemma is. So, like I said, lemma, or probably you must have already understood that, or read about it in school, that a lemma is actually a proven statement that is used to prove another statement. I'll tell you what it is used for, what is proven in it, and what it is used to prove. So I'll tell you about that. But basically, what is proven is that for any two positive integers a and b, so if we have two integers, say a and b, they say that there exists a unique quotient and a unique remainder such that a is equal to b cube plus r. Now, this is a very important thing to understand. A is equal to b cube plus r is a formula that we are going to use our entire 2 years or 3 years, whatever we are left with in school. So right from class 10th, 11th, 12th, it will be used everywhere. And it's not a very difficult formula to understand or to remember if you understand the concept behind it, or why is it used. So let me give you a very simple example of how it is used. For example, if I take a number 7 and I divide it by 2. So if I divide 7 by 2, you know that 2 goes into 7 3 times. So 2 times 3 is 6. So I write 6 here. I subtract 6 from the 7, and I'm left with the remainder as 1. Now, A here is the dividend. So this is the dividend. Do remember that. Dividend. So that means 7 is the dividend here. I'll mark it with a capital D, or let me say A. So this is A, and B is the number that we are dividing by. So B is the divisor. In this case, the divisor is 2. So that is B. Q is the quotient. So this happens to be the quotient. And R is the remainder. So R1 here happens to be the remainder. So this is how it is, and 7 can then be written as plus 1. So similarly, if we take a number like 13 and we divide it by 3, so we can write 13 as 3 times 4, which is 12, and then it leaves a remainder of 1. So it's a very simple formula where A is a greater number, B is the smaller number. So we're dividing the bigger number by the smaller number, and we get a quotient and a remainder. And what is important is that it's a unique quotient and a unique remainder, that if A and B are fixed, they cannot change, then the quotient and the remainder have to be the same. There is no other way you can apply any other thing. So you can't say that 13 can also be written as 3 times 3 plus 4, because it is very important that this remainder should not be greater than the divisor. So it has to be less than the divisor. So the condition is that R is greater than or equal to 0, but it is less than B. We'll understand more about it in the coming slide. And the last point, what do we prove it for? What do we use Euclid's division lemma to prove? Is to check for divisibility by numbers. So we are divisibility of big expressions, or maybe big numbers, to check whether they are divisible by small numbers or not. So that's what we are going to understand as we go into it. Let me take an example to make things more clear for you, so that you understand it by heart. So what I'm going to do is that I am going to take the numbers from 12 to 20, check divisibility of numbers by 4 from 12 to 20. So let me excuse me, let me write the numbers: 12, 13, 14, 15, 16, 17, 18, 19, and where do I write 20? Okay, 20. So we have to check divisibility of these numbers by 4. So what happens when we divide by 4? So 12 can be written as 4 times 3, which is 12, right? 13 can then be written as 4 times 3, which is 12, but it leaves a remainder of 1. So we will add 1 to that. So 4 times 3 is 12, plus 1 is 13. 14 can be written as 4 times 3, which is 12, plus it leaves a remainder of 2. 15 can be written as 4 times 3, which is 12, but it leaves a remainder of 3. 16 can simply be written as 4 times 4. So you see how the quotient has now changed. So because the number has got bigger and we are dividing by the same number, so the quotient has now become bigger and there's no remainder, because 4 times 4 is 16. 17 can be written as 4 times 4, plus it leaves a remainder of 1. 18 is nothing but 4 times 4, which is 16, plus it leaves a remainder of 2, and 19 is 4 times 4, which is 16, plus it leaves a remainder of 3. And finally, if we come to 20, the quotient changes here again, so it is 4 times 5, which is 20. Now what you need to understand is that what forms do these numbers take. Now if I look at these numbers also, like 12, 16 and 20, I see that there's no remainder. So we can just write 4 times 3 plus 0, where we see that they can all be written in the form A is equal to BQ plus R. Now I'll tell you a very simple way of how to remember this formula, because you might get confused sometimes about how it comes. I'll tell you how we used to remember it. We used to do math in a lot of fun loving ways. So it used to give us a lot of small pleasures in life by making fun of things. So this we usually used to say, अबे क्यों रुला रहा है यार. So it was like that a is equal to b q plus r. अबे क्यों रुला रहा है. So it is very simple to understand once you have the logic behind it, or once you understand, if you relate it to something else in your real life, you will understand how simple it is to learn these formulas also. Now if we look at these numbers, what forms do they take? We can say that whenever we are dividing a number by 4, it can be written as 4 times the quotient plus a remainder. So in this case it's 4q plus 0, so I don't need to write the 0, so I can just say that it takes a form 4q, or it takes the form where it leaves a remainder of 1, so 4q plus 1, or it can take the form 4q plus 2 where it leaves a remainder of 2, and here it, you see, it takes the form 4q plus 3, and here we come back to 4q plus 0, or just 4q, so that it keeps repeating 4q, then 4q plus 1, then 4q plus 2, then 4q plus 3, and back to 4q. So this is how these numbers can take the form. Now similarly, if we're dividing by 6, it will be 6q, 6q plus 1, 6q plus 2. Can you tell me the rest? I'll wait for your comments on the chat box. Okay. Can you tell me 6q plus 1, 6q plus 2? What else should I write? Okay, still waiting for your comments on the chat box. Be a little quick. Come on, guys. Okay, right. So 4q, 6q plus 1, 6q plus 2, then 6q plus 3. Sorry, 6q plus 3. It can also take the form 6q plus 4 or 6q plus 5. Can it take the form 6q plus 6? Can it? Yes, so Kushi Kumari has answered correctly. She has said that yes, it is 6q plus 3, 6q plus 4, 6q plus 5. Now Kushi, Aryan, can you tell me whether they can, whether I can write it as 6q plus 6 or not? Remember, A is equal to BQ plus R. I gave you the condition that it has to be less than, greater than or equal to 0, but it has to be less than B. But can it be equal to B or not? That is my question. She is again right, saying that no sir, we can't write it as 6q plus 5. Absolutely right, Khushi. I'm very happy because it cannot absolutely be written as 6q plus 6, because the remainder has to be less than the divisor. So like we saw here, that 4 times 3 plus 3, and then we wrote 4 times 4. So the quotient changes, the remainder cannot be written, it cannot be equal to the divisor. So that is why when we were dividing by 4, we stopped at 4q plus 3. When we are dividing by 6, we stop at 6q plus 5. Now, once we understand the concept, let us try and solve a few questions on it. That if n is an odd integer, prove that n square minus 1 is always a multiple of 8. Now, this is a very common question which almost comes in every board exam and might come in yours too. If it doesn't come in the board exams, it will definitely come in your unit test. So be prepared with this question, because they say that let us understand, and let us also understand what mistakes people generally make when they are trying to solve these questions. So if we know that n is an odd integer, now odd, when we talk about even and odd, we know that even number is that which can be divided by 2, and odd number is one which cannot be divided by 2, or it leaves a remainder of 1. So when divided by 2, the number can be written in the form 2q, or it can be written in the form 2q plus 1. So if an n is an odd integer, we'll definitely have to take 2q plus 1, and we have to prove that n square minus 1 is always a multiple of 8. So let us try with 2q minus 1, where we take n is equal to 2q plus 1, and let's find the value of n square minus 1. So in that case, n square would be 2q plus 1 whole square, and we have got the minus 1 at the end, so let's write that also. We'll expand this, so this is a simple expansion of a plus b whole square. So a plus b whole square we know is a square, which is 2q whole square, plus b square, which is 1 square, plus 2ab, so 2 times a, which is 2q, times b, which is 1, and we have got the minus 1 at the end. So that can then be simplified as 4q square plus 1 plus 2 times 2q times 1 is just 4q, and minus 1 at the end. Now what plus 1 and minus 1, they can get cancelled, and we are just left with 4q square plus 4q. Now this didn't work. Unfortunately, when we took the number as 2q plus 1, we are able to get it in the form 4q square plus 4q, or we can simply take factorize 4 and write it as q square plus q. But we know that the number is a multiple of 4 for sure, but whether it is a multiple of 8, we don't know that. So that is what mistake we make. So generally we stop here and we say it didn't work. I don't know how to do maths. It will never happen to me. I will not be a good student in maths. That's how we try and give up. But it's very important to understand that how else can we write an odd integer as. Let's check with the divisibility by 4. So if we divide a number by 4, if we take the number as 4q, uh, would that be an even number or an odd number? Well, if it is a multiple of 4, if you look at the multiples of 4, we have got 4, 8, 12, 16, 20. Are they all odd numbers or even numbers? Well, they are definitely all even numbers. In no case can we get an odd number. But what if it can be written in the form 4q plus 1? So numbers like which is one more than the number. So I can say like 5, 9, 13, 17. These all leave a remainder of 1, and these are all odd numbers. So yes, it can be written in the form 4q plus 1. What about 4q plus 2? 4q plus 2, well, 4q is a multiple of 4, so that is an even number. If you add 2 to that, that again gives you an even number. So the other odd number can be 4q plus 3. Now let's check with this whether we get a multiple of 8 or not. So let me take case number 1. Case 1, where n is equal to 4q plus 1. So let's find the value of n square minus 1. So n square would in that case would be written as 4q plus 1 whole square and minus 1. Then again, like we simplified here, we'll take the square of 4q, which is 16q square, a square plus b square. So we've got 1 square is 1, plus 2ab. So 2 times 4q will give us 8q. 8q times 1 will give us 8q again. And then we have got minus 1 at the end. So again, plus 1 and minus 1 can get cancelled. Now out of these two terms, 16q square and 8q, we can definitely factor out 8, and we can write it as taking 8 as common. We can leave it as 2q square plus q. Now you see that this number, if we take as k or m or any other integer, so this is going to be definitely an integer because q was an integer in the beginning. So integer square is an integer, 2 times that is an integer, and if you add an integer to that, so the closure property you are all aware about. So whatever operations we apply to an integer except for division, it's always going to be an integer. So 8 times k, so definitely it is a multiple of k, 8 in the first case. Now let us have a look at case number 2 also. Case 2, we saw that the number could be where n was taking the form 4q plus 3. Okay, so in that case, let us look at the value of what n square minus 1 is. So n square minus 1 in that case would be 4q plus 3 whole square and minus 1. Now help me simplify it, can you? Okay, and 4q plus 3 whole square minus 1. So 4q whole square will be 16q square, the same as the first one. Now b square is going to be different because there we had 1 square was 1. Here we have got 3 square is going to be 9. So we can write it as 9, and then 2ab. So 2 times 4q is going to be 8q. 8q times 3 is going to be 24q, and minus 1 at the end. So let's again simplify this because 9 and minus 1 are like terms. So let's combine those. So we can write it as 16q square plus 24q, and 9 minus 1 is plus 8. Again we can factor out the 8 and we can write it as 2q square plus 3q plus 1. Now again, since q is an integer, this whole thing is going to be an integer, and let's say this is m. So 8m, this again you see is a multiple of 8. Now since we had only two possible cases for odd numbers to be there, 4q plus 1 or 4q plus 3, there is no other possibility, and in both the cases we have got it as a multiple of 8, we can surely say that n square minus 1 is always a multiple of 8. That's how it is easy it is. Have you understood, or you want me to explain a little further? Let me go ahead with it. Okay, Aryan says no, sir. Uh, okay, that was to the previous question. And right, let's go a little further. I'm sure as we keep doing questions, you'll get the hang of it and you'll understand that how it is done. Now, in this question, what we have to prove is that n square minus 1 is even for any positive integer. Now here when we are talking about even, we just need to prove that it's a multiple of 2. So for that it is very simple. We take just two cases, and because it says any positive integer, it could be an even positive integer or it could be an odd positive integer. So again we have got two cases here. So case 1 and case 2. Let me write the number of cases first. So in the case 1 we can say that n is of the form 2q, where it's an even number, or in case number 2 if it's an odd number, so we can say n is equal to 2q plus 1. Now let's solve in both the cases that what is the value of n square minus n. So we have to find the value of n square minus n for both the cases. So let's substitute the value of n as 2q in this equation. So we get 2q whole square minus 2q. So 2q whole square is nothing but 4q square minus 2q. Now again I can factorize 2 out of that, so I can write it as 2q square minus q. Now again, if this is an integer like k, we see that it is a multiple of 2. So definitely case 1 n square minus n is even because it's a multiple of 2. If it's a multiple of 2, it's going to be even. Let's look at case number 2 where we have n as 2q plus 1. So we write 2q plus 1 whole square and minus n. So minus n again we'll take it as 2q plus 1. So 2q plus 1. Let's simplify it. So 2q whole square gives us 4q square. 1 square gives us just 1. 2 times 2q is 4q times 1, which is again 4q, and we have got this. So we'll distribute the minus sign to both these terms. So we'll get minus 2q minus 1. Now we see that the plus 1 and minus 1 can be cancelled, and 4q and 2q, they can be combined together. So let me write it as 4q square plus 4q minus 2q is plus 2q. So again I can factorize out 2 from here, so I am left with 2q square plus q. Now again, if we take this as an integer, let's say m, we again see that it's a multiple of 2 because it can be written in the form 2m. So again in this case also we can say that n square minus 1, n square minus n is even. So since there were only two possible cases, this one, and for both the cases that we have proved that it is even, we can say that n square minus n is always an even number for any positive integer that we take. Right. So let us understand a little further about what numbers we can take. Let us move to the next slide. Uh, any questions you have so far? No? Okay. So prove that the cube of any positive integer is of the form 9q, 9q plus 1 or 9q plus 8. Now again you can take it as a guarantee this question is going to come in the board exams or in your unit test. At least one of them it will definitely come. So let's understand. And again let's understand what mistakes people may make. So now we have to take any positive integer and we have to prove that it is divisible by 9 or it leaves a remainder of 1 or 8 when it is divided by 9. So if we have to check divisibility by 9, definitely taking n as 2q or 2q plus 1 is not going to help us, because even if we find the cube of 2q, it is going to give us 8q cube, and that does not tell us anything about divisibility by 9. What if I take the numbers as 3q or 3q plus 1 or 3q plus 2? Any positive integer can also be written in these forms. Now what happens when we cube these numbers? So 3q cube is going to give us 27q cube, and that definitely is going to be divisible by 9. So let's try and work it out this way, that there are three possible cases. So case 1 is where it takes the form 3q, case 2 where it is of the form 3q plus 1, or case 3 where it is of the form 3q plus 2. So we know that n is equal to 3q in the first case. So we have to find the cube of any positive integer. So let's find out n cube first. N cube is going to be 3q whole cube, which, which is going to be 27q cube. In case number 2, so again let me write it as 9 times 3q cube. So we can say that if this number is k, so it can be written in the form 9k. So it is definitely of the form 9q. So it can take the form 9q, right? Let us look at case number 2, where we have to find n is equal to 3q plus 1. So n cube is what we have to find out, which is 3q plus 1 whole cube. Now for this, I want to remind you of an identity that you've learned in your earlier classes, that a plus b whole cube. Can you tell me what a plus b whole cube is going to be? Okay, a plus b whole cube is going to be a cube plus b cube plus 3ab times a plus b. Have you learned this identity? You have read about it in your earlier class, in your ninth class? I'm sure you must have. So let us apply this identity over here and find out what the value of n cube is going to be, or 3q plus 1 whole cube is going to be. So it starts off with a cube. So that's going to be 3q whole cube plus b cube, which is 1 cube, plus 3ab. So I can write it as 3 times 3q times 1 times a plus b. So a plus b is just 3q plus 1. So I'll write it like that only. So this can then be simplified. 3q whole cube can be written as 27q cube plus 1 cube can be written as 1 plus 3 times 3q is going to be 9q, and let me write it as 9q times 3q plus 1. Let's simplify it a step further. So 27q cube plus 1 plus 9q times 3q is 27q square plus 9q times 1 is 9q. Now do we have any like terms here? No, nothing. So we can just write it as I can factor out 9. So I can, what I'll left with, be left with is 3q cube in the first case. 1 is not divisible by 9. So let me leave that for a minute. I'll write that later. 27q square divided by 9 will give me 3q square. And 9q divided by 9 is going to give me only q. And because we had left out the 1 earlier, we can write it as plus 1. So you see that if this number is k, so again it can be written in the form 9k plus 1. So we have proved the second condition also, that it can be the cube of any positive integer can be of the form 9q plus 1 also. Let's have a look at the case number 3. So in this case we are going to take n as 3q plus 2, and we are going to find the value of n cube, which is going to be 3q plus 2 whole cube. Now let me write it a little here. So that is going to be equal to 3q cube plus 2 cube plus 3 times a, which is 3q, times b, which is 2, times a plus b, which is 3q plus 2. So that will give us 27q cube plus 2 cube is going to be 8 plus 3 times 3q is 9q, 9q times 2 is 18q, and 18q times 3q plus 2. Let's open this bracket also and find out what we get. So we get 27q cube plus 8 plus 18q times 3q is going to be 54q plus 18q plus times 2 is going to be 36q. Q square, 54q square, sorry. Any like terms here? No, no like terms. So just let me rewrite it or factorize out 9 out of it. So again, if we factorize out 9, we'll get 3q cube. 8 is not divisible by 9, so let me leave that for a minute. 54q square divided by 9 is going to give me 6q square, and 36q times divided by 9 is going to give me 4q. And because we had left out the 8 earlier, let me write it here. So again you see that we have got 9 times a number which can, sorry, that went wrong. 9 times a number which can be written as k. So it takes the form 9k plus 8. So we have proved the third condition also. And since there were only 3 possible cases of the number that we took, there is no other possibility for the number to take the number n to take any other form. And since we have found out that it can only leave it will either be divisible by 9, or it will leave a remainder of 1, or it will leave a remainder of 8, nothing else. There is no other possibility. So we can just write it like that, and that is the end of the question. Right. Okay, and let us move to the next slide. We have to prove that the square of any positive integer cannot take the form 3q plus 2. Okay, uh, so can you tell me what to write here? What should I write? What could we get? How will we check the divisibility? Okay, let me explain it to you that of any positive integer, and it cannot take the form 3q plus 2. So again it is clear that we are looking at divisibility by 3. So we are looking at 3, and because if we take the numbers as 2q and 2q plus 1, that won't tell us anything about the divisibility by 3. Let us take the number n as 3q, 3q plus 1, or 3q plus 2, because it is talking about any positive integer. So again we have got 3 cases. So case 1 where n is equal to 3q, case 2 what have I written the spelling of Q case as? Already feeling sleepy. Case 2, where n can take the form 3q plus 1, or case number 3, where n can take the form 3q plus 2. And what do we have to prove? We have to prove that the square of that number. So we are going to look at n square. So let us find out what n square is going to be. If n is 3q, n square is going to be 3q square. So that is going to be 9q square. Am I right? Okay. And because we have to check the divisibility by 3, let me factorize out 3. So we can write it as 3 times 3q square, which means it is taking the form 3k or 3q, whatever you want to say. It leaves no remainder. It is a multiple of 3. If we look at case number 2, so n was equal to 3q plus 1. So therefore n square is going to be 3q plus 1 whole square. That is going to be 9q square plus b square. 1 square is again 1, and 2ab, 2 times a is 6q, times 1 is again 6q. I can factorize out 3 from some of these terms. So I can write it as 3 times 3q square. 1 is not divisible by 3. Let me leave it. 6q can be written as 2q. And plus 1 because I had left out the 1. So if I take this as k, it can then be written in the form 3k plus 1. So again, it can take the form 3k, it can take the form 3k plus 1. Let us look at case number 3 also, whether it can take the form 3q plus 2 or not. So n square is what we need to find out. N square will be 3q plus 2 whole square. That will be a square. So 3q whole square is going to be 9q square plus b square. So 2 square is going to be 4 plus 2ab. So 2 times 3q is 6q times 2 is 12q. That's it. So again, now here I want to make a little change. 4 can then be, I can write it as, actually I can write 9q square plus 12q, and instead of 4 I'll write it as 3 plus 1, because 4 can be written as 3 times 1 plus 1. It leaves a remainder of 1. So again I'll convert 4 in the form bq plus r. So again, if I factorize out 3, I'll be left with 3q square plus 4q plus 1, and in the end we have again got plus 1. So again, if I take this number as k, it will take the form 3k plus 1. And because there were only 3 possible cases and we have covered all the cases, and in the first case we found it was a multiple of 3, in the other 2 cases we found it leaves a remainder of 1, so it can never take the form 3q plus 2. So this is indeed quite correct, and we have proved that. Right. Very good evening to you, Mr. Nitesh. Thank you for joining the stream. And you're a little late, but not too late. And I'm sure we are still going to understand a lot of things. A very warm welcome to you. Okay, let's continue further to the next slide that we have. So we've got proof that for any positive, for any integer n. So let us take the integer as n. We have to prove that n cube plus 2n is of the form 3k, where k is an integer. Now again, if we take n as 2q or 2q plus 1, and we have to check divisibility by 3, it's not going to be possible. So we have to take again 3 possible cases, where we take the possible cases as case 1, where n is going to be 3q, case number 2, where n is going to be 3q plus 1, and case number 3 where n is going to be n is equal to 3 cube plus 2. Okay, so case 1, if n is equal to 3 cube, we have to find the value of n cube plus 2n. So that will be equal to 3q whole cube plus 2n, so 2 times 3q. That will give us 3q whole cube is 27q cube plus 2 times 3q is going to be 6q, and we can factorize out the 3, so we'll be left with 9q cube plus 2q. If we take this number as k, we find that it is of the form 3k. So first case is proved. Second case, where n is equal to 3 cube plus 1, we have to find n cube plus 2n, which is going to be 3 cube plus 1 whole cube plus 2 times n, which is 3 cube plus 1. So that will be equal to 3 cube plus 1 whole cube is going to be 27 cube plus 1 cube is going to be 1 plus 3ab. So 3 times 3q is 9q times 1 is 9q times 3q plus 1, and 2 times 3q is 6q, and 2 plus 2 times 1 is going to be 2. So let me simplify that. Let me open this bracket first. So I get 27q cube plus 1 and 2. I can write it together as 3 at the end. And here I'll be left with 27q square plus 9q. 9q plus 6q, I can write it as 15q. And then we can factorize out the 3, sorry. So that's going to be 9q cube plus 9q plus 9q, sorry, 9q square, that's right. Then 5q, and 3 can again be divided by 3, so plus 1. So again we are left with nothing outside the bracket. So again, if we take this number as k, it can be written in the form 3k. So again we have proved it for case number 2 also. Let's try and prove the same thing for case number 3, where n cube plus 2n will then become 3 cube plus 2 whole cube plus 2 times n, which is 3 cube plus 2. So this can be written as 27q cube plus 2 cube is 8 plus 3 times 3q is 9q. 9q times 2 is 18q. 18q times 3q plus 2. And I can open these brackets, so that will give me 6q plus 4. So let me simplify this. So I'll be left with 27q cube, 8 I'll leave it for the time being. 18q times 3q gives me 54q square, and 18q times 2 gives me 36q plus 6q, and 8 plus 4 can be written as 12. Let me write it here. Okay. So that is, we can factorize at the 3 now. So we'll be left with 9q cube plus 18q square plus 36 divided by 3 gives us 12q. Sorry, we've got 6q also. So let me combine that in one step. So 36q plus 6q gives me 42q, and 42 divided by 3 gives me 14q, and 12 can again be divisible by 3, so that's going to give me 4. So again, if we write this as k, we can write it in the form 3k, and we have proved it for case number 3 also. And since there were only 3 possible cases and we have placed it, we have thought about it, we have uh, uh, we basically understood that it will always take the form 3q. Now, Kushi says that there is a problem, screen is becoming blur. Okay, now Kushi, this is actually a YouTube problem. There might be some streaming issues, or your internet connection might not be good. So, what happens, what you can do in the best cases, that on the top you will see the three dots. If you click on the three dots, sorry, not on the top, it will be the at the bottom if you are watching it on a desktop. So if you click on the three dots, you will get an option for quality. If you choose quality, it will probably be selected at auto quality, but you can click on choose high quality, and if you click on high quality, you will be able to see it better. So then you'll be able to see it better, right? And in case it still doesn't get solved, do let me know. I'll probably it might not be issue at my end because I can see everything is right here. So just try that, and I'm sure you'll be able to see it. Right. So I think that's for now, and this is about Euclid division lemma. And I think it's time that we move to, okay, last question for division lemma, I think, yes. So again, last question, if n is equal to 6k plus 5, where k is a positive integer, so again, it can, they have given that it is of the form 6k plus 5. So no different cases here, only one possible case where it is 6k plus 5. We have to find what is the remainder when n square is divided by 6. So first let us find that n is equal to 6k plus 5. That is given to us, and we what we have to find out is n square. So basically what we have to do is it will become not q, sorry, it will be 6k. We should always write what is given in the question. So 6k plus 5 whole square. So 6k a square will give me 36k square, plus b square will give me 5 times 5 25, plus 2ab, so 2 times 6k is 12k, 12k times 5 is 60k. Now again I can rewrite this as 36k square plus 60k, and instead of 25 I'll break up the 25. So what will be 25 when divided by 6? What do we get? Because we have to check divisibility by 6, right? So we can write it in the form a is equal to bq plus r. So 25 can be written as 6 times 4, which is 24, plus it leaves a remainder of 1. So let me write 25. Instead of 25, I'm going to write 6 times 4 plus 1. Sorry, no bracket here. Okay. Now I can factorize out 6 every time I make a problem when I make a mistake when I say this word. Factorize out the 6. I'll be left with 6k square plus 10k, and 6 is factored out, so I'm left with plus 4, and because 1 is not divisible by 6, let me write it outside the bracket. So because there was only one possible case where it was 6k plus 5, and we have covered that, and if we take this number as q, we can see that when divided by 6 it leaves the remainder of 1. So if a number is of the form 6k plus 5, for example, if the number is say 11, or if it is 17, or if it is 23, or if it is 29, if you divide these numbers by 6, it will always, if you square these numbers and then divide by 6, you will always find that you will get a remainder of 1 in all the cases, right? Let's move to the next question now. And this is basically, I'm going to gradually come on to Euclid's division algorithm now. So let us understand that what the lemma is used to prove. So just a minute. Mm. So if we proof, if we look at the proof is that it is basically used to find the HCF of two numbers. Now if we understand the proof, very easy to understand, nothing complicated in it. So let me write the general formula of Euclid's division lemma, which is A is equal to BQ plus R. So what we are going to do is that if we want to find the HCF of A and B, HCF of A and B, then to find that we can write A is equal to BQ plus R. Now there are two possible cases, that R will either be 0, that means there is no remainder, or it will leave some remainder. Now if it leaves some remainder, what you can do is you can just bring this B number here, so we'll get it here, B is equal to, and you can get R here, so we'll get RQ plus R1. Now that is because if you find, if R is the remainder, then if you just find the HCF of B and R, and that will be the HCF for A and B as well. So let's understand. So in case R1 is again not 0, we'll again bring R here, find the HCF of R. We can write R as R1Q plus Rn. So this will keep continuing till we come back, till we get Rn is equal to 0. So we'll keep doing the on and on and on till Rn is going to be 0. And when Rn is 0, we can take the divisor and say that that is the HCF. So in this case, if Rn is equal to 0, then R1 is the divisor. Is the HCF. And HCF not only for B and R, it's going to be for A and B as well. Now let us understand with the help of an example, that you'll understand it very well from this example, and I'm sure that if you understand it well, do write it in the comment section that you've loved the example, you have understood it very clearly once I explain it to you. And once again, before I explain it to you, be sure that you have liked the video, and do not forget to click on the like button, which is right below the video. Just click on the like button. It gives me some motivation that if I am teaching you and you're liking it, you're liking the video, so it helps me a bit, and definitely I'm going to like it. Thank you so much, and let's move on. And HCF of 30 and 48. So like, I'll first show you how I explained it to you, that basically we have to find HCF of 30 and 48. So we'll write it in the form A is equal to BQ plus R, where A is always the larger number of the two. So I'm going to write it that 48 can be written as 30. It has to be divided by 30. Now 48 and 30 are fixed in this case, and it has a unique quotient and a unique remainder. So what is the quotient going to be? So 30 times 1 is 30, 30 times 2 is 60, which is going to be more than 48. So it is only going to be 30 times 1, which is 30, plus how much remainder does it leave? 18. Now since I told you that if the remainder is 0, then we can say that the divisor is the HCF. So in this case, HCF is not equal to 30 because the remainder is not 0. So the next step is that you have to bring this number here. You can write 30 is equal to, bring the 18 down here. So 18 times how much is 30? 18 times 1 is 18. 18 times 2 is 36, which is more than 30. So obviously we can't take it 2 times. It has to be 1, plus it leaves the remainder of 12. Now again 12 is not 0. So we'll have to continue. So we, in the next step, we bring 18 here. So here now we were finding out the HCF of 30 and 18. In this case, you bring 18 here. 18 can be written as 12 times something. So here we are trying to find out the HCF of 18 and 12. So 18 is equal to 12 times 1 is 12, 12 times 2 is 24, which is more than 18. So I can write it as 12 times 1 plus it leaves a remainder of 6. Now again 6 is not 0, so I'll have to continue. I'll have to go a step further. So I bring the 12 here, I bring the 6 down here. So 12 can be written as 6 times something. So here we are trying to find the HCF of 12 and 6. So 12 can be written as 6 times 2, which is equal to, or 6 times 2 plus 0. Uh, so because we have got the remainder as 0, we stop here and we say that this divisor is the HCF. So we can say that HCF is 6. HCF of this also is 6, of this also is 6, if this also is 6, and of this also is 6. So we can write that the HCF of 30 and 48 is 6. Now tell me, are you much clearer with this example or not? Do you understand how Euclid's division lemma is going to be used? Or this is an introduction to the Euclid's division algorithm now. So this is how the algorithm is going to be used, and I'm going to tell you a little more about it. We'll do a couple of questions also, but I want to explain it to you in one other way also. That let's take a rectangle. So let's take that this length is 30, and let me take this breadth as, this breadth as 30 and the length as 48. So not a very straight rectangle, slightly crooked lines, but it serves the purpose. So basically what we are trying to do is we have to make squares, cut out squares out of this rectangle. So if we look at the first square, so if the breadth is 30, to make it a square, we will have to cut it out from here, so that it divides it into two parts. So we have got uh, uh, 30 here, so this is also 30 and this is 18. Now the rectangle, this is already a square, so we don't have to worry about that. Now we are going to look at a rectangle and make a square out of that. So we divide it into a square again. So if this length is 18, this is also going to be 18, and this is then going to be 12, and this is also 18, right? Now again we'll have to make a square out of it. So again I take it like this, like this, where this part is 12 and this is 6. Now again, if this is 12, we have to divide it into two parts, two squares. So I get two squares of side 6 each. So you see that how we are, when we keep on converting a rectangle into smaller squares, the smallest square that we get is the HCF. So that's what we are going to do here. We have taken a rectangle 30 and 48, divided into squares, and we found that the smallest square that we got was 6 units long. Okay, thank you, Neelu ma'am. Thank you very much. It is my pleasure that I am um, I'm explaining the concept to children and they're learning something out of it. Thank you so much, ma'am. Okay, and let's move to the next example, Euclid's division algorithm. Like I told you, what is the concept behind it? So algorithm, if I talk about algorithm is nothing but a set of steps or a set of rules that must be followed when you are solving a particular problem. So I'll give you a very simple example of uh, like when you make tea. What happens when you make tea? So when you're making tea, what you have to do is you have to take some water and some milk. So usually you take about 80% water and 20% milk, or it depends on your taste. You can take it as 70% water and 30% milk, or some people even like it 60% water and 40% milk. So you add some water and milk, bring it to a boil, and once it comes to a boil, you add some uh, grated ginger in it, so get a nice flavor, and you add the tea leaves. Let it simmer down for about 10-15 minutes, so that you get a nice wonderful aromatic flavor out of the tea. And once you get that, then you just bring it to a boil again, switch off the gas, and pour it into cups and add sugar to your taste. So that is the algorithm for making tea. Now similarly, there's an algorithm or a recipe for everything. So if we understand the recipe for this, for division, we'll understand how we can solve a particular problem. So basically, uh, mhm. So the steps that are involved in this are that we apply the Euclid's division lemma to the numbers and write them in the form A is equal to BQ plus R, where I told you that A is the greater number out of the two and B is the smaller number. So it can always be written in the form BQ plus R, where R has to be less than B. So let me write that here, that uh, R is greater than or equal to 0, but it is less than B. Okay, so make sure you write it in that form. That is the first step. Second step is that if R is equal to 0, then the HCF is B. That's sure. B is the smaller number. Or if R is not equal to 0, you have to apply the Euclid's division lemma to again to B and R, where you write it in the form B is equal to RQ plus some remainder, which let's call it Rn. Now there are two possibilities. If Rn is 0, then R is the HCF, or if Rn is not equal to 0, you go back to step 2 and keep doing it, keep repeating the step until you get Rn is equal to 0. When Rn becomes 0, then whatever R was there in the end, that is going to be the HCF. Okay, let's understand using a simple example. So we have to find the HCF of 84 and 56. So 84 can be written in the form, so I have to write it in the form A is equal to BQ plus R, where A is the greater number or the bigger number. So 84 can be written as 56 times how much? 56 times 1 is 56. 56 times 2 is 112. So obviously it can be one time. And what remainder does it leave? It leaves a remainder of 28. So then I bring the 56 here and I bring the 28 here. So 56 can be written as 28 times 2 plus it leaves a remainder of 0. Now since 0 is the remainder, the HCF obviously is the divisor here. So HCF of 84 and 56 we can say is equal to 28. That's how simple it is. Simple, isn't it? If yes, just give me a thumbs up in the uh, chat box, and I'll remind you to click on the like button if you really like the video, and if you want access to all our videos and you want to be notified of our future uploads, do click on the subscribe button also, so that all live streams and all, so basically about live streams, I'll tell you that every Sunday I'm going to do a live stream. I've got two channels. One is an English channel, which is this one, Exponent to Success. The other is a Hindi channel. So you can search for it on YouTube. I'll write the name. So the name is going to be Ganit Kavya. So if you just search for Ganit Kavya on YouTube, you'll find a channel, and you'll find my picture also on it as the icon, and you can subscribe to that also, because next week I'm planning to do it on my Hindi channel. And yeah, so I'll do it alternative weeks. So one week, first week, third week, I'm going to do it on the English channel. Second week, fourth week, I'm going to do it on the Hindi channel. So do subscribe to both the channels. Do click on the like button, and let's move forward. Right. Next question that we have is we have to find HCF of 24 and 64 using Euclid's division algorithm. So uh, again, let me write it in the form A is equal to BQ plus R. Here we have to find HCF of 24 and 64. So let me take the bigger number first. 64 can be written as 20, sorry, not 28. It's going to be 24. 24 times 1 is 24, 24 times 2 is 48, 24 times 3 is 72. That is going to be greater than 64, so it can be only 24 times 2, which is 48, and then it leaves the remainder of 16. So 16 is not 0. That means we'll have to continue a step further. We'll bring this 24 here. We'll bring this 16 here. So 24 can be written as 16 times 1 is 16. 16 times 2 is 32, which is more than 24. So it can only be 16 times 1. Plus it leaves a remainder of 8. So again, 8 is not equal to 0. I bring the 16 here. I bring the 8 here, and 16 can be written as 8 times 2, plus it leaves no remainder. Now since the remainder is 0, this divisor is the HCF. So we can say that the HCF of 24 and 64 is 8. Now again, if we look at the example using the rectangle, you can see that if I take this length as 24 and I take this as 64. Now this is not to scale, so I may go a little wrong. You might not find it to be a square, but I can divide it into two squares. So this is 24. This again is 24. Okay, so two squares, and I'm left with 16 here. Now 16, I can, so this is 24, this is 16. So 16, I can make a square here where this part is 16 and this is 8, and because this was 16, I can divide it into two parts which each have a length of 8 units. So you see that how the 24 and 64 we have found out pictorially. Also we have done the same steps. 24 times 2, which is here, 24 times 2 plus a remainder of 16. 16 times 1 is 16, plus it leaves a remainder of 8, and 8 is divided into two parts and it leaves a remainder of 0. So we end there. That's how simple it is. And let's move to the next question. Just two more questions left, so bear with me, we'll do it very quickly. Find the HCF of 99 and 27 using the Euclid's division algorithm. So again, let me write them in the form A is equal to BQ plus R. We have to find the HCF of 99 and 27. I take the bigger number first, so 99 can be written as 27 times 1 is 27, times 2 is 54, times 3 is 81, times 4 is 108. That is going to be greater, so this can only be 27 times 3, which is 81, and it leaves the remainder of 18. Now I bring the 27 here, I bring the 18 here, so 27 can be written as 18 times 1. This is 27. 18 times 1 plus it leaves a remainder of 9. I can bring the 18 here and I can bring the 9 here. So 18 can be written as 9 times 2. So again, because the remainder is now 0, 9 is the HCF. So we can say the HCF is 9. Simple? Right. Find the largest number. Now this is another question which is very important from the board's point of view, because this definitely, such a question might come in the board exams or in your unit test. So be prepared with it, understand it properly how it is done. So find the largest number that divides 1223 and 2351, leaving remainders 90 and 85. So here we have to find the largest number that divides. That means we have to find the HCF, but we are not going to find HCFs of 1223 and 2351. They are leaving some remainder. That means 1223, if we take 1223, that can be written as some divisor, which is B. So let us say which is the HCF. So it can be written as B times Q, plus it leaves a remainder of 90. And in the second case, 2351 can be written as B, because the HCF of both is going to be B, but the quotient can be different. So let me take this as Q2 and this as Q1, plus it leaves a remainder of 85. Now if we see BQ1 will then be equal to 1223 minus 90, because 90 will then go to the other side. And here also BQ2 will be equal to 2351 minus 85, because 85 will go to the other side. Minus 85, we will find out the difference. So that is going to be 1133 in this case. And in this case, it is going to be 11 minus 5 is 6. 14 minus 8 is again 6. And 2266. Right, so these are the two numbers and we have to find HCF for these two numbers. So let me write it. HCF of 1133 and 2266. So basically I have to again write it in the form A is equal to BQ plus R. So I take the bigger number, which is 2266. That can be written as 1133 times 1 is 1133 times 2 is 2266, and it leaves a remainder of 0. Now since it leaves a remainder of 0, 1133 is the HCF. 1133. Now if you see, if we divide this number by 1133, you will get 90 as the remainder, because you will get 1133 times 1. So Q1 is going to be 1. 1133 times 1 plus 90, and this can be written as 1133 times 2, which is 2266, plus 85, which is 2351. So that's how we solve such questions. You first find out the difference of these two numbers and then find out the HCF. Right? I hope you're learning something. Okay, let's have a look at a couple of real life applications also. That where is it actually used in real life? Because I've seen that students understand a lot better when it is really related to real life. So I've already given you the example of a rectangle. Now let's read here. A rectangular floor of size 45 meters by 27 meters needs to be tiled using square tiles. Now the tiles are square, so that you have to remember that there are square tiles. So if the tiles are square, that means the length and the breadth are going to be equal. So that means we have to what should be the maximum side length of such tiles. So maximum means greatest or the highest. So immediately we come to know we have to find the HCF. And HCF of what? HCF of obviously the floor that we have. So HCF of 45 and 27 is what we need to find out. So let's find that out. It's simple. So A is equal to BQ plus R, where A is the bigger number, 45 is equal to B is the smaller number, 27. 27 times 2 is 54, that becomes more than that. So 27 times 1, which is 27, plus how much remainder does it leave? 18. Now 18 is not equal to 0, so we bring the 27 here. That can then be written as 18 times something. We bring the 18 here. Can be only times 1, plus it leaves a remainder of 9. Now again 9 is not 0, so we'll have to continue. So 18 can then be written as 9 will come here. 9 times 2, which is 18, plus a remainder of 0. Now since the remainder is 0, the HCF is going to be 9. So that means the square tiles that we have will have a side length of 9 units or 9 meters. And how many tiles will be needed? So you can find out the area of the room. 45 times 27 divided by the area of the tiles, which is 9 times 9. So 9 times 5 is 45 and 9 times 3 is 27. So that means 15 such tiles will be needed to tile the complete floor. That's how simple it is. Right. Okay. Who's this? Interesting name, Astronaut Gaming. Good evening, Astronaut, or whatever your real name is. Good evening and welcome to the stream. You're quite late. We are actually just ending. We are right on the last question now. So the last question is that mason has to fit a bathroom floor with square marble tiles of the largest possible size. The size of the bathroom floor is 17.5 feet by 12.5 feet. What would be the side length of each tile in inches? So again, these are square tiles. So that means the length and breadth will be the same. So we have to find the side length of each tile and in inches. That's the important part. That means the 17.5 feet, we'll have to convert it into inches, and the 12.5 feet again we'll have to convert it into inches. Now what do we get when we um, uh, uh, just a moment. Okay, sorry, there was some issue with the uh, problem. So now it's everything should be okay. So basically, what we have to do is we have to convert 17.5 feet and 12.5 feet into inches. So to convert it into inches, we first have to know how many inches are there in 1 feet. 1 foot is consists of 12 inches. So obviously, we'll have to multiply it by 12. So 17.5 multiplied by 12, and 12.5 multiplied by 12. So again 12.5 multiplied by 12. Now 12 times 5 is 60. The decimal point will come there. 6 carried forward. 12 times 7 is 84, and plus 6 is 90. 9 carried forward. 12 times 1 is 12, plus 9 is 21. So 210 inches. And the breadth of the floor is 12.5 multiplied by 12. So 12 times 5 is 60. The decimal point 6 carried forward. 12 times 2 is 24, plus 6 is 30. 3 carried forward. 12 times 1 is 12, plus 3 is 15. So 150 inches. So basically we now have to find the HCF of 210 and 150. So again, let's write it in the form A is equal to BQ plus R. So 210 can be written as 150 times 2 will be 300. So obviously it has to be 150 times 1, plus it leaves a remainder of 60. 60 is not 0. We'll have to continue. 150 comes here. That will be equal to 60 comes here. 60 times 2 will be 120, plus it leaves a remainder of 30. Now again we have not got the remainder as 0, so we'll have to continue. 60 comes here. 60 will then be equal to 30 comes here. 30 times 2, which is 60, plus it leaves a remainder of 0. And now because the remainder is 0, this is the HCF. So the HCF of this and this is 30. So each tile should have a side length of 30 inches. Side length is equal to 30 inches. So this is how masons and contractors, they do their work. They understand. Uh, so this they are actually, they are not educated people. They don't know. They don't have the knowledge that you have, but they are practically applying themselves. So that this is all they have to do, and because they are going to they have become so good with it, it's natural for them. So like I said, we have to understand the things, and once you understand the logic, we are going to be able to solve any problem that we have, any real life application or any problem that we get. Now of course I'm open to your suggestions also. I'm open to your questions also. In case you do have any questions, you please put it right in the chat box right now, so that I'm able to help you with it. And in case you do not have any questions, I will give you my email address. You can contact me, and we'll you can send me your questions and I'll answer them to you right over email, or I will send a mail to you, or I will probably specially make a video for you if I can even do that much. So my email address, I'm just showing it here at the bottom of the screen. uh, just feel free to send me an email whenever you want. and this is my email address. So you can write to me at vikas@sharma.es. It's a very simple email to remember if you remember my name and my company's name. So Vikas Sharma is my name. So it's Vikas@Sharma, and the name of my company is Exponent to Success, which adds an exponent to your learning curve. And so exponent to success, the short form is ES. So Vikas@Sharma.es. So just send me a mail anytime you want, any question you have, any topic you have, just send me a question. Or if you want me to make a video on any particular topic, just send me a request on my email, or just leave a comment on any one of my videos on my channel, and I'll be sure to make a video on it. Right, though most of videos related to the 10th class topics I've already made, and you can see them in the chat box. Right. So with that, I would once again like to remind you that if you haven't liked the video as yet, just click on the like button, so that I get some motivation out of it, that you've liked it, you've enjoyed the stream. And if you haven't subscribed to the channel as yet, do subscribe it to right now, because then you will, and do not forget to hit on the bell notification also, because then you will get access to all our live streams. You will get notifications whenever a live stream is coming up. And like I told you, a live stream will be held every week at 5 p.m. on Sunday. So it will be alternatively. This week it is on this channel. On next week it will be on my Hindi channel. My Hindi channel's name is Ganitavya. So that stream will be in Hindi totally. And you can just search for Ganitavya on YouTube, and do subscribe to the channel, hit the bell notification, and I'll see you on the stream next Sunday. Okay, I've got Shivani and Khushi saying thank you. Thank you very much, Shivani, and thank you very much, Khushi, and thank you all of you wonderful people who have taken the time out to understand this Euclid's division lemma and Euclid's division algorithm. Next week we are obviously going to be doing uh, something on fundamental theorem of arithmetic, which is the next topic in your real numbers chapter. So I'll see you then in the next video, and till then, take care. God bless. Bye.